The very beginning of the design process started with us designing the shape of Garfunkus's face. You can see Logan here, and his beautiful artwork of Garfunkus the Clown here. This is Logan recreating the face that Garfunkus is making. While Logan was doing that, I was writing up the paragraph of the problem that Garfunkus the Clown had, as you can see here. After a while, Logan finished the body of Garfunkus. You can see his body is now fleshed out. He has a nice vest and a bow tie. You can also see that he's holding up his hand with some more balloons. This is when Logan began to outline his body with black marker. While he was doing that, I was finishing up the paragraph. I suppose it was already finished though, so I didn't really help outline though, I mostly colored. After that, you can see that Garfunkus is mostly colored in now. His blue vest, his green bow tie and green makeup, red nose, red balloons, orange shirt. I shaded in the majority of the shirt and the vest, I think, while Logan finished up outlining him and coloring him as well. After that, you can see that we added these two rubber bands here after we put holes in the board. These rubber bands were to hold the Garfunking device, or to hold the syringe that inflated and deflated the balloon. You can see Logan inserting the syringe into the two rubber bands there, with the balloon attached to the syringe. After that, we cut into the sides of the poster board. As you can see, this side was already cut into. You can see that it's longer here than it is here. This was so that we could fold the sides back after we reinforced the back of them with a little bit of tape. This would allow us to be able to stand the poster board upright at a 90-degree angle for presentations. You can see how he uses a ruler and the box cutter to make straight lines down the side of the poster board. However, he does not cut so deep that he cuts into the back side of the paper. The other side of the poster board was used as like a hinge to have the paper fold back and forth on the sides. We also reinforced this back with some packing tape. Here, you can see the Garfunking device in action. As you pull down on the device, it deflates the balloon a little bit. You can see that, like here. Now, it doesn't deflate it by very much, but it does, just a little bit. And as you push back up, it reinflates the balloon. And this is how you can demonstrate the balloon inflating and deflating. The problem is, Garfunkus the Clown is blowing up balloons for terrorizing the neighborhood kids. Using his Garfunking device, he can fill air into a balloon at a rate of 1,200 cubic centimeters per second. Starting from a volume of 0, Garfunkus usually inflates balloons to a circular shape and to a radius of 12 centimeters. What is the rate of change of the radius of the circular balloon? After Garfunkus Garfunks the balloon, inflates it using the Garfunking device, for 3 seconds. In order to solve this problem, we must declare our variables and our different rates of change. We remember that we had the rate of change of volume that Garfunkus would put into the balloon, which was 1,200 cubic centimeters per second. This is one that we will definitely need to be remembering. Right here. We'll also have to recall that the volume of a sphere, which is the shape that Garfunkus blows the balloons up into, is for the equation for the volume of a sphere is 4/3 pi r cubed. This will also come in handy for when we solve the problem. In order to solve this problem, what we must do is we must take this here equation and we must derivatize it so that volume becomes the rate of change, dV over dt, and everything else here also, derivatizes with respect to time. And to do that, when we do that, we get dV over dt and that's going to be equal to 4/3 pi. Now this r cubed is going to be our variable, so this is going to become 3r squared dr over dt. Bingo. From here, make it a better arrow. From here, we get dr over dt is equal to dv over dt divided by this 4/3 pi r squared. 4/3 times 3 pi r squared. And that would just end up being 12 pi over 3, which would just be 4 pi, right? Whoops. 4 pi. And then the r squared. And now we have this equation right here. The equation of the derivative with respect to time. Using this information, we may zoom out a little bit, give myself a little bit more room. Okay. Now using this equation, we can use this variable here that we know, as well as time being 3 seconds. Something else we'll need to know. The equation for volume and the equation that we derived ourselves. So, we first must find the volume that the sphere is at, that the balloon is at, after 3 seconds. To do that, it is just the amount of air that Garfunks into the balloon, multiplied by 3, because it's over 3 seconds. It's 3,600, pretty easy. So, the volume is 3,600. That's going to be equal to 4/3 pi r cubed. So that we can find what the radius is. So, 4/3 pi r cubed. In order to find the radius, r, that is not a very good looking r is going to be equal to 4/3. Just kidding, I'm reading the wrong thing. R is going to be equal to the cubed root of 3,600 divided by 4/3 pi, and that is equal to 9.5. Bingo. That's our radius. Now, we may plug everything that we have into this here derivative equation. So, we have dr over dt, which is what we are trying to find, which is equal to dv over dt, which is 1,200. That is divided by 4 pi r squared. 4 pi. R is 9.5 squared. Bingo. We can plug this into our calculator, and we will find that the rate of change of the radius of the balloon at 3 seconds is approximately 0.88033 centimeters per second.